Let's look at our example number 4 of trigonometric identities. Here I have tangent of theta plus cotangent of theta plus secant of theta plus cosecant of theta. And on the right hand side I have 1 plus sine of theta, 1 plus cosine of theta, secant of theta, cosecant of theta minus 1. And I need to prove this identity. Either I can prove the left hand side into the right hand side, or what I can do, I can prove the right hand side to the left hand side. And seeing this problem, both sides look as much as intimidating as the other. So what I'll do over here, first I'm going to prove the left hand side into the right hand side, then I'm going to prove the right hand side to the left hand side. So first I'm going to prove the left hand side onto the right hand side. So if I want to prove the left hand side to the right hand side, my step number 1 is always going to be converting my tangent, cotangent, secant and cosecant functions into sine and cosine. So in place of tan theta, I can write sine theta upon cosine theta. So sine theta upon cosine theta. And in place of cot theta, it means 1 upon tan theta, which means cosine of theta upon sine theta. So in place of cot theta, I'll write cosine of theta divided by sine of theta. Similarly, in place of sec theta, I'll write 1 upon cosine theta. So plus 1 upon cosine of theta. And in place of cosec of theta, I'll write 1 upon sine of theta. The next step, if I want to bring these terms into this form, you can see that this expression over here is in a single fraction. So I'll combine all these fractions by taking LCM. The LCM of all of these is going to be sine theta cosine theta. So sine theta cosine of theta, and I'll need to multiply this fraction by sine of theta. So this becomes sine theta times sine theta, and cosine of theta gets multiplied by cosine of theta, so cosine of theta times cosine of theta, and this fraction gets multiplied by sine of theta, so plus sine theta, and this by cosine of theta, so plus cosine of theta. Simplifying, this would give me sine square theta plus cosine square theta plus sine theta plus cosine theta divided by sine theta cosine theta. Now we know sine square theta plus cosine square theta is equal to 1 using the first Pythagorean identity. So in place of these two, I'm going to rewrite 1. So this becomes 1 plus sine theta plus cosine theta divided by sine theta cosine theta. Now I have this expression over here, but I need to form this into this form, and I have a minus 1 over here which I don't have over here. So what I'll do over here, to introduce this minus 1, I'll write plus 1 minus 1. Plus 1 minus 1 means 0. So introducing plus 1 minus 1 is going to have no effect on the expression. But what it's going to do, it's going to help me bring this minus 1 in order to prove this identity. Next, I'll take the LCM till this positive 1 so that my minus 1 does not get affected. So when I take the LCM with this positive 1, so this becomes 1 plus sine theta plus cosine theta, and when 1 gets multiplied by sine theta cosine theta, it becomes sine theta cosine theta divided by sine theta cosine theta, and this minus 1 is going to be over here. Next, in the numerator, you can see that these two terms both have a cosine function in it. So I can factor these out by taking cosine common. So if I take cosine common in these two terms, this becomes cosine of theta times 1 plus sine of theta. And in my first two terms, there's nothing common, so I'll take 1 common to factor this out. So this becomes 1 times 1 plus sine theta, and there is a positive sign in between, so plus here, and divided by sine theta cosine theta. These two brackets over here both are the same, so I can write this factor 1 times, so this becomes 1 plus sine theta times 1 plus cosine theta divided by sine theta cosine theta, and minus 1 here. Now you can see that this expression that I have now has a 1 plus sine theta in it, and the identity that I needed to prove this in had a 1 plus sine theta. This has a 1 plus cosine theta, this also has a 1 plus cosine theta, but this does not have a secant of theta. And to introduce this secant of theta, I am going to break this fraction up by writing sine theta cosine theta separately. So this would be 1 plus sine theta times 1 plus cosine theta times 1 upon sine theta times 1 upon cosine theta minus 1. And 1 upon sine theta means cosecant of theta, so this would be 1 plus sine theta times 1 plus cosine theta times cosecant of theta, and 1 upon cosine of theta means secant of theta, so secant of theta minus 1. I can also interchange these two by writing secant of theta first and cosecant of theta second, because these two are getting multiplied. So this means that this expression over here is this expression here. So I have proven my identity on the left hand side to the right hand side. Now let's look at how would we prove this identity if I converted the right hand side into the left hand side. Now in order to prove the right hand side onto the left hand side, my first step is always going to be writing my trigonometric functions in terms of sine theta and cosine theta. So if I do this, my right hand side would become 1 plus sine of theta times 1 plus cosine of theta times 1 upon cosine of theta, because sec theta means 1 upon cosine theta, times 1 upon sine theta minus 1. This I can write as 1 plus sine theta times 1 plus cosine theta divided by cosine theta sine theta minus 1. Now next I am going to multiply both of these factors, and that would give me 1 times 1 is 1, and 1 times cosine of theta would be cosine of theta, and sine theta times 1 would be sine of theta, and sine of theta times cosine of theta would be sine theta times cosine theta divided by cosine theta sine theta and minus 1 here. Next I am going to take the LCM of this fraction and this minus 1, so this would get multiplied by cosine of theta sine theta and cosine of theta sine theta in the numerator also. So this would become 1 plus cosine theta plus sine theta plus sine theta cosine theta, and when minus 1 gets multiplied by cosine theta sine theta, this would be minus cosine theta sine theta and divided by cosine theta sine theta. Cosine theta sine theta can be written as sine theta cosine theta, so these two would cancel each other out, and I am left with 1 plus cosine theta plus sine theta divided by cosine of theta sine theta. Now this is the expression that I have made from the right hand side, and if I need to bring this in the form of the expression on the left hand side, notice over here that there is no positive 1. There is no 1 over here. So if I need to remove this 1, I would need to bring trigonometric functions in place of this 1. And that can only be done by this first formula of Pythagorean identity. In place of 1, I am going to bring sine square theta plus cosine square theta. So this would become sine square theta plus cosine square theta plus cosine theta plus sine theta, and the denominator is cosine theta sine theta. So cosine theta sine theta. Now for the final step, I am going to break this fraction up. I am going to write every term in the numerator with my denominator cosine theta sine theta. So this would be sine square theta divided by cosine theta sine theta and plus cosine square theta divided by cosine theta sine theta and plus cosine theta divided by cosine theta sine theta and plus sine theta divided by cosine theta sine theta. This sine theta cancels out with this sine theta, this cosine theta cancels out with this cosine theta, this cosine theta would cancel one cosine theta from the numerator, and this sine theta would cancel one sine theta from the numerator. So I am left with sine theta upon cosine theta. Here I am left with cosine theta upon sine theta. Here I am left with 1 upon sine theta, and here I have 1 upon cosine theta. Sine theta upon cosine theta can be written as tangent of theta. So tangent of theta, and cosine of theta divided by sine theta can be written as cotangent of theta. So plus cotangent of theta, and 1 upon sine theta can be written as cosecant of theta. So plus cosec theta, and 1 upon cos theta can be written as sec theta. So plus sec theta. This was the expression on the left hand side. So I have proven my identity.